Hello guys, welcome to Superchem video lessons. This lesson is on organic chemistry, and then it's the very first lesson of a series of video lessons we are going to have on organic chemistry. So this very first lesson is going to be an introduction to organic chemistry. So first and foremost, let's ask ourselves, what is organic chemistry? Organic chemistry is an aspect of chemistry that deals with organic compounds and their properties. Deals with organic compounds and their properties. So what are organic compounds? All right. So organic compounds, they are a special group of compounds which have carbon atoms, and then their carbon atoms are covalently bonded to hydrogen atoms. Then sometimes they are also bonded to few other elements like oxygen and nitrogen. When you look around us, there are a lot of substances we can see and touch that are made up of organic compounds, like sugar, table sugar, gasoline, diesel, petrol. They are made up of organic compounds. Wood, cooking oil, plastics, drugs in our pharmaceutical shops, perfumes, alcohol, fabrics like nylon, and then the DNA in the cells within our bodies are all made up of organic compounds. So some examples of organic compounds are methane. Methane right here is the simplest organic compound you would ever come across. And then benzene, a very popular organic compound. And then we have ethanoic acid. So here are three examples of organic compounds. Now it should be noted, this is very essential, that organic compounds are not always compounds that contain carbon atoms. So when you can come across compounds that have carbon in them, but they are not organic compounds. So for example, oxides of carbon, like carbon monoxide and carbon dioxide, they have carbon, but they are not regarded as organic compounds. And then carbonates like sodium carbonate, calcium carbonate, they are also not regarded as organic compounds, even though they have carbon atom in them. And cyanides like hydrogen cyanide, copper cyanide have carbon, but they are not also considered as organic compounds, as well as carbides such as calcium carbide and silicon carbide, having carbon but are not amongst organic compounds. So what is so special about carbon? What are the special unique properties of carbon that makes it so dynamic and versatile in forming the vast array of organic compounds we have? Alright, so we are looking at three properties of carbon that makes carbon able to form the many organic compounds we have. First is that carbons have the ability to bond with themselves to form long chains. So many carbons can come together to form straight chains or linear chains. They can also form complex structures that have branches. Then they can also form rings, cyclic kind of structures. So this ability of carbon to form long chains and different types of chains is referred to as catenation. Alright, so secondly, carbon has the ability to form 4 covalent bonds. How does it do that? Alright, so let's check out the electronic configuration of carbon. So when you check out the electronic configuration of carbon here, you realize that on the last shell it has some electrons on it. So it has 4 valence electrons. So it is these 4 valence electrons that carbon uses to form 4 covalent bonds with other carbon atoms or entirely different atoms. So it has 4 covalent bonds. It can form 4 covalent bonds with its 4 valence electrons. We are moving on to the third one. They have the ability to form single bonds and double bonds, as well as triple bonds. They form single bonds when they undergo sp3 hybridization. They can also form double bonds when they undergo sp2 hybridization, as well as the triple bonds when they undergo sp hybridization. So there you have it, the 3 special abilities or properties of carbon. Okay, so now moving on to classification of organic compounds. We can first of all classify organic compounds into 2 main groups. The first group is hydrocarbons, and then the second group, calling them hydrocarbon derivatives. So what is the main difference between these two? Alright, so for hydrocarbons, they only contain carbon and hydrogen atoms, whereas for hydrocarbon derivatives, they have hydrogen, carbon, and then other elements. So let's check out an example of a hydrocarbon. So here you have an example of a hydrocarbon which has 4 carbon atoms and then a lot of hydrogen atoms around it. So you see that it only has carbon and hydrogen, so it's a hydrocarbon. And then the next example, you can see that we have hydrogen and carbon, all right, but there is the presence of oxygen and nitrogen. So this makes this compound a hydrocarbon derivative. So in this lesson, we are zooming into hydrocarbons. We'll be looking at hydrocarbon derivatives in the future. But for now, let's check out some examples of hydrocarbons. Alright, so here are all hydrocarbons. So these examples are all hydrocarbons because they have only carbon and hydrogen. We can also classify hydrocarbons. So hydrocarbons can be classified into aliphatic hydrocarbons and then aromatic hydrocarbons. The aliphatic hydrocarbons can be subdivided into acyclic and then cyclic hydrocarbons. So we have acyclic aliphatic hydrocarbons and cyclic aliphatic hydrocarbons. So under acyclic hydrocarbons, we have alkanes, and then alkynes. We'll be delving deeper into this in subsequent lessons. Alright, so the cyclic, we have under it cycloalkenes, the cyclic versions of alkenes, cycloalkenes, as well as cycloalkynes. All right, and then for aromatic hydrocarbons, we are not going to classify it, but we have to mention about them that they have special ring structures, and they are also called arenes, and then they are also called benzene rings. So here are some examples of aliphatic hydrocarbons. So for acyclic, we have an example of an alkene, and then one for alkynes. So for the cyclic aliphatic hydrocarbon, we have 3 examples. This is an example of a cycloalkene. Here we have an example of a cycloalkene, and then we have an example of a cycloalkyne here. So here too we have some examples for aromatic hydrocarbon. We have benzene, we have naphthalene, and then ethyl benzene. So for all these 3 examples, you can see that they have special ring structures. You see that their rings have 3 double bonds. So that's the special feature about the arenes or the aromatic hydrocarbons. Okay, so we are ending our first lesson here. In our next lesson, we'll be looking at how to name hydrocarbons. All right, so keep calm and steady hard.